Hi friends, good morning. Myself, Mr. V.R. Sanap, lecturer of Mechanical Department from KQAK Polytechnic, Nasik. Friend, today we are going to discuss about the flexible manufacturing system. So, a flexible manufacturing system is a production method that is designed to easily adapt to changes in the type and quantity of the product being manufactured. Machines and computerized system can be configured to manufacture a variety of parts and handle changing levels of production. Flexible manufacturing system, that is FMS, can improve efficiency and thus lower a company's production cost. Flexible manufacturing also can be a key component of make to order strategy that allows customer to customize the products they want. It consists of a group of processing workstations interconnected by means of an automated material handling and storage system and controlled by integrated computer control system. So friends, in this slide we will discuss about the need of flexible manufacturing system. So the first need, high productivity for all batch sizes, it may be large or small. Then second need, shorter throughput times. Then third, lower storage cost. It reduces labor, if not altogether avoiding labor. Then next, reducing handling. Flexible production system to incorporate product changes at short notice to meet customers' specific requirement. Sensing and taking care of such eventualities like tool breakage. So these are the some need of flexible manufacturing system. Then subsystem of flexible manufacturing system. There are three major subsystems in flexible manufacturing system. The first one, computer control manufacturing equipment. For example, numerically controlled machine tools, robots, gantry loaders, palletizing system, washing stations, tool presetters, in-process inspection system. Second major subsystem, that is automated material storage, retrieval, transport and transfer system. The third subsystem, that is manufacturing control system, including both machine tool and logistic control. Some FMS have additional subsystem. For example, in a machining application, there may also be subsystem for presetting tools, storing and retrieving tools, disposing of chips and cutting fluids, washing and inspection workpieces. These subsystems must be linked together to achieve integrated manufacturing operations. FMS compared to other types of manufacturing approaches, in that first, the various manufacturing approaches can be divided into category like conventional machine, computerized controlled conventional machine, that is numerical control or computer numerical control. Then group of conventional and computerized machine, that is flexible manufacturing system. Earlier group with integrated material handling system, special purpose machine, that is SPM, and transfer line. The medium and small scale industry has less orders of job and their job keep on changing. Thus they need not use any particular setup. This industry work with traditional machines like the conventional lathe, conventional milling, shaping, and so on. So on general purpose machine, low volume and variable jobs can be economically produced. It can also be a batch production where the batches repeat after certain interval of time. Mass production of parts need to produce parts with repeatability and accuracy. In order to achieve this hard wired NC and CNC machines are used. The CNC machines can run at higher speed and are programmable. This type of GPM provides the greatest degree of flexibility. A large portion of manufacturing industry involves the intermediate level of batch operation that lend themselves to the FMS approach. In this case, volume is less, but the varieties are more. Now, the FMS compared to other types of manufacturing approaches. In this diagram, on x-axis, the variety are there, and on y-axis, the volume is there. So the figure shows the different types of production system, that is transfer line, SPM, FMS, FMC, CNC, GPM, and it can be seen from figure that FMS fits into the intermediate range of production, that is between transfer line, SPM, and FMC, CNC, and GPM. So general purpose machine can accommodate variety of parts. They are manually operated and therefore production volume are low. Then CNC machines can accommodate variety, but the production volume is less as the machine are not optimized for the highest productivity. Then FMC and FMS satisfy both variety and volume equally well. In SPM, variety is much restricted. So transfer line are dedicated to manufacture component and hence can be said to have a minimum variety. Thank you.